Welcome back to your live continuing coverage of CES 2018 on BeTerrific, your official media partner. I'm Michael Artsis. You're the Terrifics. You make BeTerrific special at BeTerrific TV on all social media. Don't forget, download the Apple TV app tonight and watch all our CES coverage on your Apple TV. You can do it for Amazon Fire, Android TV as well. We're on Twitch, we're on Facebook, we're on television, and we're on radio stations all across the nation. Thanks to the Cumulus Network. We are a huge partner of the Cumulus Network. We're building an OTT with them, and it's so exciting. This is on the OTT. I got John Riley here from Markforged. You guys do something so innovative. I have never seen this before. I've heard 3D printing, 3D printing, 3D printing, 3D printing for like 5 years. That guy right there, Adam Holtz, has like 8 3D printers in our office. We have the graveyard of 3D printing, all right? Yet I've never seen what I see here today, and I'm so excited about it. You can print in metals and composites.
That's right, yeah. We've brought 2 big innovations to the 3D printing space. They're pushing the boundaries of what's possible. So for 30 years, 3D printing has been very good at making sort of design prototypes, cosmetic validation tools for the design process, effectively plastic parts that you would use to look at and decide if they were good enough to proceed to manufacturing. What we've done is we've made actual strong parts that you can 3D print. So the first innovation was a composite part. So we take a plastic matrix material and we reinforce it with a continuous strand of carbon fiber, and that makes a part that's as strong as aluminum off of a 3D printer. So you can go ahead and feel this brake lever if you like. I'll hold the microphone. Try and give it a brake.
It's not. I can't even flex it. That is unbelievable. That's very impressive. Yeah, a little bit if I really work at it. There is a little bit of flex in carbon fiber, but so for applications like manufacturing applications where you need really strong parts that are being used to, an end of robotic arms to automate manufacturing and applications like that, now we can print your part out of a composite material instead of machining it out of aluminum, and it ends up being like 20 times cheaper than existing processes, and it's ready right away. So it's a big manufacturing tooling expansion. Potentially, could you print like hockey sticks and golf clubs? Yeah, you can print all that sort of stuff as well, and it is also a high-strength required sort of part, so we are used in a wide range of applications where strength is required. The sweet spot tends to be sort of the manufacturing industry, where they have a lot of aluminum tools that need the extra strength, so that's where we're primarily focused. And you don't do anything in aerospace? That's aerospace as well, yeah. You do? Yeah, so because it's carbon fiber and as strong as aluminum, but 40% lighter than aluminum, if you're in the aerospace industry, you care a whole lot about the weight because you're paying to fly the thing across the sky. But 3D printing, you can make it strong enough for aerospace? It's as strong as a aluminum part. So I guess so. Then that's the answer. And for the applications where you really need metal, because we're all about printing strong parts, we've introduced a metal printing technology. We call it atomic diffusion additive manufacturing. But what it is it basically takes metal powder, binds it in plastic, and prints it into the shape of your part, which you see here in the metal machine. This is our Metal X. And then you sinter it in a furnace, and it burns off the plastic, and you're left with the pure metal part. So this is a stainless steel part that's been printed on one of our machines and sintered in one of our furnaces. And oh my God! So they're just—it's just pure metal. I think they would say OMG today. The breakthrough here is that we've brought metal printing down from the $500,000 or $1 million range into a much more affordable $125,000 for the whole system, end to end. $125,000 for the whole system, and you can print parts like this. These are car parts, basically. Yeah, this is actually a brake lever from a Ducati, but you get the idea. Sorry, bike parts. Yeah. Very cool. Wow. Is there any way we could see this in action just so we can see it going? We're not running it right now. That's a finished part that's sitting on there, but you can stop by our office and see it, or visit one of our resellers and check it out, printing if you'd like. It's unbelievable. What applications does this have for the medical industry and stuff? Obviously, it's great for engines and precision manufacturing, but what about medical? Any space where you need sort of a custom part, and medical often requires this because right now when they do replacement components for people, they tend to give you a small, medium, or large. It's not optimal. Everyone is a different size. So there's a whole lot of inbound interest from the medical community because they can start to make joints and bones and replacement pieces for people that actually fit your individual need instead of a average one-size-fits-all type of solution. Plus, you can make it a lot less expensive because you can do this on demand, but it's not like you're getting a manufacturing run on demand, or you're hand tooling this. You're letting a machine do this off of a CAD or something like that.
Yeah, that's been one of the long-term values of 3D printing, has been that in small to medium-sized runs, making a tool takes a long time. It becomes expensive. It's much easier, cheaper, and faster to 3D print those parts. So the more unique the part, the more appropriate it is for 3D printing.
How big do these 3D printers get for you?
This is our largest one, so its size is 300 millimeters by 220 by 180 in the Z. So it's.
What's the future?
Over time, these are going to be used in larger and larger production volume. So you'll see people stacking these up in parallel and using them to print high-volume mass production parts at scale.
When you look 20 years in the future, you think people will basically make everything in their home with a printer like this that prints metals, plastics, carbons?
I actually don't think that that's the future. I don't see why you'd need a manufacturing facility in your house. Most people don't know how to use CAD programs. I think that lives at like the last mile facility, like an Amazon fulfillment warehouse, where if you need something, you order it and someone delivers it immediately to your house. I don't believe in a future where these machines are going to live in everyone's everyday homes, but I could be wrong.
Very cool. Can you just run me through some of these products you guys have 3D printed out of metal
Sure.
as we go?
I'll walk you through the booth a little
Oh, yeah, let's do this. Whoa. Hey,
So,
what is that?
This is an Insteron, and what it does is we've...
I hold on. I got to get on this side so I don't block the camera shot. I was so blown away, I stopped producing myself in my head and walked into the camera shot. An Insteron. I like the name.
So what it does is it proves out the tensile strength of material of your part. So what we've done for the show is we've 3D printed and then sintered some metal dog bones, they're called. You put them in both ends of the gripper jaw on this pull tester, and it pulls them until they break. And it shows you the strength and stretch characteristics, the strength, stiffness, and elongation of break characteristics of the metal. So you can validate for engineers who would be using it to design that it actually works like they'd expect.
So technically, you could make a part for the aerospace industry or an automobile, and then test the part, and then make another one.
The point of the testing is to prove that the part has the material characteristics and properties that we claim that it does.
I got you.
Anyone who actually uses this part in their facility or in a car or in a plane is going to do their own testing much like this. So at the show, we're validating that, in fact, yes, the parts that you can 3D print are just as strong as the parts you could make through traditional manufacturing methods.
I thought you were showing a QC process. I got it. Okay.
Let's. And then over here we can take a look at some of our composite machines. Here, we'll scoot over. So this is our Mark II, and these parts over here are showing some of the ways we print composites. So what we have here is a continuous fiber that's wound throughout the plastic matrix, and that's what gives the part its strength. Normal 3D printed parts would just have the plastic component here. You wouldn't see that continuous fiber reinforcement throughout the part. And so this is the thing that makes strong parts on the composite side. This printer has two materials that it lays down. One is the matrix material, and the second is the reinforcing fiber. And here's one of the completed brake levers that we've just printed. We'll probably be scraping that off in a second and starting another print.
And this is something. So the other machine was in the $150,000 range for the whole setup. This is something that's in what kind of price range?
It's much more affordable. So this is $13,500. It's sort of a desktop size composite printer where anyone can start to print with composites. And then we have an industrial series as well, which is over here to the left. Which is where you need like a larger format build envelope, and you're looking for a little bit higher resolution parts with the same like great reinforcement technology. This is our X7. You can make a lot larger parts here if you're making large manufacturing tooling or big fixtures or work holding or any sort of part that you need strength and size. This is the machine for you.
And we can see it printing now, which is really nice.
Yeah, absolutely.
Very, very cool.
And then if we want to take a look at some of our demo displays over here, the last section of our booth.
Well, hold on one second. We're admiring the printing process. We haven't seen anything print yet.
Let me show you something. One of the cool things about how we print is we do it at room temperature, so you can actually pause the print mid-print. It'll lower the print bed, and you can take the print bed out of the machine. And so this is the continuous fiber that just got cut there. If you wanted to design a cavity in the part to put a piece of metal into or something, you could have an automatic pause set in software. It's all handled in software. And then you can, when you're done putting any components in, just dock it back into the machine and then just hit resume and it'll go right back to printing.
And it's not hot. You touch that.
Yeah, it's not printing very hot. The nozzles are hot. You wouldn't want to touch them because they're melting the material to apply it to the part. But the part itself is room temperature.
Very cool. I'm very impressed by this. I got to tell you something. This is very, very impressive. You guys have done a great job, and this is something that's very important and has a great use. And I'm glad we were able to showcase this and kind of, bring it to the light of day, because this is one of the most innovative things I've seen in a long time, and certainly here at CES 2018. So, yeah, walk me through some of these things.
These are some example parts where we have some of our best application fits in the market. So these are one of our sort of lead case studies. It's this company called Dixon Valve and Coupling, and they make end effector. They make valves and couplings, but they have a robot arm in their manufacturing process with end effectors on it. They were previously machining those out of aluminum, which was expensive and had a long lead time. The average cost per jaw here was $285. Now that they can print it in a part that's just as strong on one of our printers, that cost drops to $9.45, and they get the part the same day.
Wow.
There's 3 of those on every robot arm and every step of their process, which is incredibly automated. So once you see these types of real-world applications that aren't just doing a cosmetic prototype for the part, but are actually being used in high-strength needed requirements, you get an application that actually matters. It pushes the space of 3D printing forward quite a bit.
Very, very cool. Thank you so much for sharing. I really appreciate it. It's Markforged, and he's John Riley. You got to check this company out. I mean, they're doing amazing things. And you know what? It's really going to revolutionize manufacturing. I know that you don't think it's going to take it to the home. I kind of like what you said, where it's going to be the last mile at the Amazon factory, but it's going to revolutionize the way we get products and deal with products, and we get what we need, and the speed and brevity and the customization, like you said, especially in medical and also in aerospace. So I got to thank you so much for joining us. I got to thank you so much for joining us. And stay with us. We got a lot more to come live on BeTerrific at CES 2018. Don't go anywhere.